welcome to my channel. In this video series, I will solve the different question papers of Assam State Electricity Board. The first paper I have taken here is of APDCL JE. The total number of questions was 100, out of which 60 were technical and the other 40 were non-technical. The first question here is from induction motor. It is given here that the squirrel cage induction motor has a rotor copper loss of 500 watt and a slip of 4%. We need to find out the input power of the rotor. So input power, we know the formula for input power is equal to rotor copper loss divided by the slip. So here copper loss is given as 500 and we have a slip as 4%. So if we solve this, we'll get around 12.5 kilowatt. So answer is 12.5 kilowatt. Next question, it is given here to match the following. The first is given here magnetic field strength. Magnetic field strength, it is denoted by H, and we know that H is equal to I by twice by R. So the unit will be ampere per meter. So it will be option 3. Next, magnetic flux. Magnetic flux, we know it is given by Weber. Then we have magnetic flux density. Magnetic flux density is always given by the Tesla. Then finally, the last option is 1 ampere turn per Weber for reluctance. So if we match with this one, it will be option D. It's given field strength as the ampere per turn. This one. So next question we have here is if X is equal to dynamically induced EMF and Y statically induced EMF, the EMF induced in a single phase transformer and in a DC generator are. We know that the single phase transformers, the EMF induced is always statically induced. So for transformer it will be Y, and for DC generator it will be X. For generator it will be X. So answer will be YX. It is given by the option 2. Next question we have, it is given here a coil of negligible resistance has an inductance of 100 millihenry. The current passing through the coil changes from 2 ampere to 4 ampere. So change of current DI is from 2 ampere to 4 ampere. So DI will be of 2 ampere. Now at a uniform rate of 0.1 second. The voltage across the coil during this would be, so if we write E equal to, we are only taking the magnitude L di by dt. So L is given here as 100 millihenry, that is 100 to 10 to the power minus 3. Then di I have found out 2 and the is 0.1. The time is 0.1. So if we solve this, we will get 2 volt. Next question, we have a magnetic circuit here. The value of L1, that is of one inductance, is given as 5 Henry, L2 is given as 5 Henry. What is we have to find out the equivalent inductance. We know that in equivalent inductance, this is L1 plus L2. We can see here it is opposing itself, so it will be minus twice M, where M is the mutual inductance. Now M is not given. How will you find out M? We can find out from this K value is given. We know that M is equal to K root over L1 L2. Okay, if you substitute the values, what we'll get will 0.5 into L1 L2 is 25, root over 25 is 5, so it will be 2.5. Now if you substitute these values, if you solve it, it will be 10 minus 5, so it will be 5 Henry. So option B is the correct answer here. Next question, it is given here that a voltmeter connected across the terminals of a dry cell reads 1.4. Okay, it is when it is open circuited. So it is open circuited, the voltage is 1.4. The voltmeter reads 1.2 when the cell delivers a 3 ampere. So assuming the voltmeter is idle, the internal resistance of the circuit, we can simply find out R equal to V by I. V is given as 1.4, 1.2 divided by 3. So if we solve this, it will get 0.066. So answer C will be the correct answer. Next, here we have the certain network consists of 2 voltage source and a large number of resistors. The power consumed in one of the resistors is 6 watt. So P1 we can write it here as 6 watt. When either of the two sources is active and the other source is replaced by a short circuit, the power consumed by the same resistor when both the sources are simultaneously active would be. So here from this, when either of the two sources is active and the other source is replaced by a short circuit. So from this we can say that we can apply here which theorem, we can apply the superposition theorem. So superposition theorem, if we apply, first we'll have to find out the power P1. P1 we know that I1 square into R. And similarly P2 will be I2 square into R. Now the if we both the sources are active, then what will be the current? Current will I will be equal to I1 square plus I1 plus I2. Okay. Now if you substitute this value, what we'll get? We will get here I1 equal to root over P1 by R, and I2 will be equal to root over P2 by R. So now we need to find out the total power consumed. So the total power consumed we can find out if we replace the four values here. It will be P will be equal to root over P1 plus root over P2. It will be whole square. So P, or we can write it this in terms of R. If we write it this into R, I square into R, or if I let me write this again. What will be P? P will be I square R. Okay, what is I square? I square we have found out that it will be P1 by R plus root over P1 by R, okay, whole square into R. Now if you solve this, you can find out R square, you can take common, okay, we can find out, we'll cancel it out, and it will be root over P1 plus root over P2, okay, whole square. So if we solve this, 2 into root into, it will be 2 square 4, 4 into 6, it will be 24. So answer will be 24 watt. Or since we will have a plus minus here, it will be, or you can hit, it will be 0. Okay, so option 1 is the correct one. Next question is the temperature coefficient of a paper. It is the temperature coefficient of a paper or a rubber. It is always negative, and it is always dependent on the temperature. We know that the formula for R equal to it is dependent on the formula, that is, it is always dependent upon the temperature coefficient alpha. Okay, it is dependent on the, so negative for the temperature coefficient of a paper. It is always negative, and it is dependent on the temperature. Okay, that's all for this video. In the next video, I'll solve the other remaining questions.